So we are adding on to what we've been learning and sort of really putting a ton of things together. 19. Whoa. Okay. Today we're talking about polynomial zeros. Yesterday we wanted our polynomial factored. Rewrite it in factored form. And factored form is where we have all of the bubbles, okay? But today we want to find the zeros. And when they're asking for zeros, they actually want to know what does x equal. So not just the bubbles, but one extra step where we solve for x. And so today, in order to solve for x, maybe we can double bubble. But for most of them, you're going to have to use the quadratic formula. The quadratic formula works all the time for finding the zeros, especially when numbers are so big you don't want to try to factor. Most of them are going to require that you use the quadratic formula. So what is the quadratic formula? X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, ladies and gentlemen, I'm pretty sure that I am going to give you a test question where it's literally, what is the quadratic formula? Which one, A, B, C, or D, is the quadratic formula? Like, pick which one matches this, A, B, C, or D. Like, it's really going to mess you up if you don't know it. Like, that's a give me points question, right? You must have this memorized. All right, it's absolutely the most important formula for Algebra 2. We use it all the time. You have to know how to make it work correctly. So we will be using that today. Now, in your homework, these first problems are just doing the division where we're going to write the quotient plus the remainder over the divisor. Exactly what we did yesterday. For those of you that weren't here yesterday, you got to watch the videos. I'm sorry, you have to do this work. For those of you that didn't bother to do the worksheet on Friday or bothered instead to copy the worksheet on Friday, and yes, I know you did that, just copy the key from a photo. All this stuff from Friday, yesterday, today, tomorrow, so important. This is like 40% of your test, which is coming soon. A test on all of this stuff. You absolutely need to do your homework. Yesterday's homework assignment, CP66, you needed to finish it at home. It's imperative that you finish it at home, that you know how to do it. Today's assignment, you're going to need to finish it at home. It's absolutely essential that you get it done. So please, ladies and gentlemen, do your homework. It's really important. Okay, so we're going to try a couple here. So really pay attention to directions, ladies and gentlemen. This is that second grouping of problems. Given one zero of the polynomial function, find the other zeros. So today, we actually want to find the other zeros. They're giving us one of them, and that's what this number is. They're giving us a 0. Whenever they're giving us a 0, they're giving us a solution for x. They're telling us that, hey, one of the answers, one of the solutions is x equals 10. And in this class, in Algebra 2, the big takeaway, like this is like quintessential Algebra 2, the big takeaway is that we're not just solving for x anymore. In Algebra 1, you solved for x all the time. That was like 3/4 of your year was solving for x, okay? And now, we're not just solving for x, but that when we solve for x, it has meaning. And that meaning is that the graph is doing something. And right here, when x is 10, we're solving to say that x equals 10, and that is an x-intercept, where the graph crosses the x-axis. And every time you solve for x, you're getting an x-intercept. Okay, so there's a connection between solving for x and the connection to the graph. Tomorrow we take it one step further where you have to use a graphing calculator to get going, okay? So Friday, you factored by hand. Everything could be factored by hand. That was huge. Yesterday, you couldn't factor the polynomial by hand. You had to use synthetic division to get started, and then you could continue the factoring. Today, we want to go one step further and actually find the zeros. So finding all the places where the graph crosses the axis. The reason they're called zeros is because this is an ordered pair. The ordered pair would be 10, 0. It's a 0 for the y value, and that's why it's called a 0, okay? So when we set it equal to 0. All right, so what we're going to do is we're going to take our solution, our 0, and we're going to use that in synthetic division. Now, if you remember from yesterday, when we're using synthetic division, we need to make sure we've got all of our powers of x. We've got x cubed, x squared, x to the first, and then x to the 0. Everything's accounted for. We don't need to fill in any placeholders with a 0. So I can go ahead and write my coefficients: 2, -14, -56, and -40. Down. You taking notes? Yes. Did you write that? Nice. Keep going. All right. Now we can go ahead and do the synthetic division, and synthetic division is a weird magical process. So it starts with combining. 2 plus 0 is 2, and then we multiply. 2 times 10 gives you what? 20. And then you combine. -14 and 20 is 6. And then you multiply. 6 times 10, 60, positive 60. And then you combine -56 and 60, 4. And then you multiply. 4 times 10, 40. And on this one, -40 and positive 40 is 0, and this last number is always your remainder. For these, because it was a 0, it should have a remainder of 0. And so that's absolutely correct. Our job is to find the other zeros. So what I need to do is convert the 2, 6, and 4 back into a polynomial. We started with 2x cubed. That's what this 2 represented, 2x cubed. And we're dividing out an x. So now what does this 2 represent? 2x squared, yes. And they count down from there. So this is the polynomial 2x squared plus 6x plus 4. And since we want to find the other zeros, we set it equal to 0, and we're going to solve for x. Well, what do you notice about that polynomial there? It has a GCF. Yeah, what's the GCF? 2. So I'm going to go ahead and take out a 2. If I take out the 2, what's left behind? X squared plus 3x plus 2. Good. These are nice small numbers, so I'm going to go ahead and try to double bubble, and it does. God bless you. Double bubble. X times x is x squared. I just gave my own answer. What times what is positive 2? 1 times 2. Positive 1 and a positive 2. How do you know if you did that right? Check the rainbow. Please remember to check the rainbow. 2x plus 1x gives us our 3x. So always, always check the rainbow. Now, to actually find the zeros, this would be factored. That's what we did yesterday, writing it in bubbles. But this is not fully factored. We're missing a bubble. What's the other bubble we're missing? X minus 10. This is what we did yesterday. We wrote all the bubbles. There should have been 3 bubbles because it was x to the 3rd power. But today we just need to find the other zeros. So I'm going to go ahead and set each bubble equal to 0. And we get solutions for x. So if we move the 1 over, we get x equals -1. And what's the other solution for x? -2, yeah. So we get x equals -1 and x equals -2. And those have that connection to the graph. So now that I know those values, -1 and -2 are x-intercepts. So my polynomial looks something like that. And again, it's something you could check on your graphing calculator. That's why you're supposed to have a graphing calculator. A lot of this stuff you can do just with your graphing calculator. All right, so maybe you can factor. 2 of these type of problems today factor. The first 2, but then the others are like this. Letter B. F of x equals 9x cubed plus 6x squared plus 61x plus 170. And they tell us that we have a 0 of x equals -2. So the solution, x equals -2, is what we get to use in synthetic division. And again, when I look, the first thing I do always when I look at a polynomial, see if I can factor by hand, because that is always going to be the fastest way. But those numbers are way too big for me to even think about that. So I'm going to go ahead and do my synthetic division. So I get to put my -2 on the outside. What goes along the top? 9, then 6, then 61, and then 170. Whoops. 170. All the coefficients, we've got all of our x powers accounted for. And then we can fill it in. How do you do the synthetic division? Bring down the 9, and then we're going to multiply. 9 times -2. 6 and -18. -12. -12 times -2 is +24. 61 and 24 is 85. 85 times -2 is -160 and 170. And +170 and -170 makes a remainder of 0. All right, so then I have my quotient here. We need to convert it back to a polynomial with x's. So what is that polynomial? 9 x squared. And then what? Minus 12x, thank you. And then plus 85, thank you very much. And we want to find the zeros. And that means set it equal to 0. And again, I'm going to try to factor this, but those numbers are so big, I don't even want to bother. So I'm going to go to the quadratic formula. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And before I can use that quadratic formula, I'm going to figure out my a, b, and c. So what's the a value? 9. And the b? -12. And the c? 85. So I'm going to go ahead and plug that information in. And I'm going to use my calculator for a lot of it. But I'm going to go ahead and write it in. This is the opposite of our b. That's what that means. Opposite of our b would be +12. Plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. So I literally just plugged all the a, b, and c in. And now I'm going to use my calculator to figure out this thing underneath the radical. When you're using your calculators, ladies and gentlemen, please, we wrote it with parentheses, use parentheses. You don't use parentheses, I guarantee you're going to get it wrong. All right, this is going to be a giant number. So I plugged it in using parentheses. There it is. Okay. Exactly how I wrote it, and it's a giant number. 12 plus or minus the square root of negative 2916. Huge number. And that's all being divided by 2 times 9, which is 18. Now, I'm going to try this in my calculator, just the 2916. Because it's so big, it's the square root of 2916. I'm going to see if it works out nicely. Oh, and look at that. It really did. The square root of 2916 is 54. So that's kind of nice. So I'm going to go ahead, say x equals 12 plus or minus. Now, we have to clean up the square root of negative 2916. What's the square root of a negative give us? Imaginary. You can get imaginary solutions. And what's the square root of 2916? 54. Yeah, it's our calculator told us that. So we get 54i for cleaning up that radical. And then I'm going to divide each of those by my denominator of 18, and that's just going to ensure that I reduced correctly. So we get x equals, what is 12 over 18? 2/3. You can divide by 6. So 2 over 3 and plus or minus. And I'm going to try 54 divided by 18, and it divides evenly. So that's nice. So that just turns out to be 3i. So there are 2 solutions for x there. 2/3 plus 3i and 2/3 minus 3i. And what was the other solution? They gave it to us right there, x equals -2. So in this particular case, the fundamental theorem of algebra, and this is like all of algebra 2, the fundamental theorem of algebra says that if you look at the highest power, which is known as the degree of the function, that degree tells you how many answers you should get, all right? How many solutions for x that there are. And it's the total of your real solution. So we have one real solution, and then we have 2 imaginary solutions. And if you add those together, you get 3. So there's 1 real solution, 2 imaginary solution, for a total of 3 complex solutions, okay? And so when you're solving for x, it's important to count those up and make sure you've got them all, okay? All right, ladies and gentlemen, this is the bulk of what you're doing today. It's a process. You need a calculator, okay? Go ahead and get started. Remember, the first group of problems is what we did yesterday. Just divide and write the quotient plus remainder over divisor. Make sure you fill in any holes with zeros.